I wanted to go over some density problems, especially when it comes to rearranging this formula. You're going to have this on the test, so this isn't really a big deal. But what you guys typically forget is how to move stuff around. So really what I want to show you guys is that it's really not hard, and it's not anything you haven't done before. So I'll tackle this first one, rearranging to mass, and then rearranging to find volume. Okay, really what I want to get in your heads is that you guys see this as a math problem, right? If I were to write D and V and put numbers instead, so that this is 1 is equal to over 2, and then M, which is we're looking for mass. Let's treat mass like we would in algebra. You have some unknown, which will be x. In this case, we just say mass, right? If we have 1 is equal to x over 2, the question would be, okay, isolate or find x, find what x equals, and then you would do just your simple algebraic skills of separating x. So right now, obviously, I can't get x by itself because this 2 is bothering me. So it's in the denominator. So how do I get that 2 out of the denominator? I simply just multiply to get it out, to cancel it on this side. Whatever I do to the right side, I do to the left side because of this equal sign. And that's pretty much it. Now I'm left with 2.1 is equal to x. So then x is equal to 2.1 is just 2 is equal to x. And you've essentially isolated the same thing. And I'll stop and I'll erase that, right? We isolated x, but I want to show you that it's the same thing as math. Instead of using numbers, we'll just use letters. Okay, so we have all of this. I want to isolate x, isolate m. So I'm going to have density is equal to mass over volume. I can't get mass by itself unless I get rid of that volume. So I'll just multiply volume on both sides. Whatever I do to this side, I do to this side. Now this cancels out, and I'm left with m equals density times volume, or x equals, in this case, density would be 1, volume is, 2. Volume would be that 2. But it's the same exact thing. It's just algebra. Okay? Now I'll solve for volume, but we start at the same place. Density is equal to mass over volume. Now I want volume, and volume is at the top, right? I want this to be in the numerator. So I can do the same exact process. I want to multiply both sides by a volume, because now maybe it's gone here, but now it's in the volume on this side. And notice that we're left with the same exact equation as we did before. Mass is equal to volume times density, except this one we just have one extra step, right? We got to the same place, now we just need to do that extra step. Remember that we want volume by itself. This density is bothering us, and we want to get rid of it. The only way to get rid of it is to divide the density out of there. Whatever I do to one side, I have to do to the other. So therefore, we find that volume is equal to mass divided by density. And that would be how we rearrange all these formulas. There's actually an easier way that I'll cover in just a second, which involves just knowing how basic cross multiplication works. And real quick, whenever you have an equal sign, and this applies for everything you'll ever do in math, whenever there's an equal sign, it means you can cross multiply, not cross cancel. Don't get that confused. The rule is cross multiply. Now, let's do the cross multiplication. I want mass. Okay, well, I want mass. That means I can take this v, just move it over there, keep my mass exactly in the same place. I'll cross multiply, and now I'll have d times v, and now I have my mass by itself. This is the first formula, density equals mass over volume. This is the second, mass equals density times volume. And I can do the third formula. If I want volume by itself, I can put the v over here and just bring the D down. So I can swap volume and density. Notice it was just a swap, and the M is always, notice that the M stays in the exact same place. You can either bring the V in there by itself to be together with D and V, or you can just swap V and D, so now they're opposites, and now you have volume equals mass over density, right? This is what I call the easy way. I like to do it the algebraic way, and not that this is not algebraic, but I find this a little too easy, and then you forget a few steps in case you ever forget during the test. Okay, now we'll solve some actual real life problems using these skills and significant figures, because we'll never be done with significant figures until the end of the year. All right, so let's solve number 4, what we're looking for. And let's read this problem together. So just like in math, in science, we start with what is given. So let's start with what is given, right? Vinegar has a density of 1.056. Okay, so my density is equal to 1.0056. This is science. We do not forget our units. Grams per ml. This is just how I write it. I write grams at the top, ml at the bottom, and you guys will eventually do too. What is the mass of 333 millimeters of vinegar? So, and I'll write this first. So I have that the other given is 333 milliliters, let's not forget the units, of vinegar. What some of you will do, including me sometimes, is I'll read this question. What is the mass of 333 millimeters of vinegar? And I'll say, okay, that's the mass. Okay, but that's wrong, right? We were looking for mass. It's asking for the mass. And your hint is always, always, always going to be in the units. We wrote down that ml. We wrote that this is the unit we're dealing with. And we know that milliliters is used whenever we're talking about volume. So it wouldn't make sense to do mass. We are looking for the mass. What is the mass? In other words, mass is the question mark. Now, I'll lower this for a second. Okay, so now that we have our givens, okay, I'll just rearrange the formula to my liking. Density is equal to mass over volume. I want mass by itself, which means I can just cross multiply that V and bring it up there. And then just erase it. Okay, and if that's not clear how I got there, I want mass by itself, so I multiply the volume out of there and I bring it over here, and that's how I got mass is equal to volume times density. Okay, now that I have my formula, everything else is just plug and chug and then check for sig figs. So, okay, we have volume, we said 333 ml, multiplied by the density, which we said is 1.0056. Don't forget the units, never forget the units, grams ml. And that's going to equal my mass. So I'm going to pull up the calculator from the textbook and resources, which is the one I want you using. And I'll go ahead and okay, go away, and then I'll just do the math. Okay, so I have 300 and, sorry, I forgot that 3 down here. 333 multiplied by 1.00056 is equal to, I'll go ahead and write that there, is equal to 334 point, and I'll write the whole thing at first. Notice that this is not the answer though. The mLs cancel out, and I can see they cancel out, and that's why I like writing it like this. So I'm left with grams, which makes sense because mass is always given in a unit of grams or kilograms or something like that. Okay, now for the sig figs, let's just make sure I did it right. Remember that the rule for multiplication for sig figs is you go with the least the one that had the least amount of sig figs. This has 1, 2, 3. That has 3 sig figs. This one has 1, 2, 3, 4, 5. That has 5 sig figs. So obviously not this one. I want this answer to have 3 sig figs. So I'll go ahead and write mass is equal to 3. That's 1 sig fig. 3. That's the second sig fig. I'm going to put the third sig fig as not 4 because I have to round. That 8 is going to affect that 4. So now I'll just write my third sig fig as 335 grams. A lot of you on the test, I would have written 334.8 as an option. I would have written 334 as an option, maybe option B, and then 335 is the correct answer. So don't get tripped up over your sig fig, especially when you get the answer right. Right? Like there's nothing more frustrating than getting everything else right and then just losing those last few points at the last second. All right? And that was for mass. This next one will be a little more complicated, but it's going to be similar to what we're going to be doing the entire semester. So it's really important that we practice it as well. And I'll rewrite this as well. All right, so always we're starting off with density equals mass over volume. Okay, well, let's go to problem number 5. All right, problem number 5 says that we want the density of iron, or no, that the density of iron is 7.9 grams per ml. What is the volume of a 500 kilogram piece of iron? So again, we'll always start with what is given, right? We are given the density. Density is equal to 7.9, sorry, I got a little ahead of myself, 7.9 grams ml, grams ml, and then that my volume is my volume 500 kilograms. Remember the units, 500 kilograms. Kilogram is not a unit of volume, it is a unit of mass, 500 kilograms, right? And this is what you'll do a lot, including I've done this all the time. I see the word volume and I'm already doing this. Volume is equal to 500 kilograms. That's not true. Kilograms isn't volume. Kilograms is a unit of mass, and it's asking what is the volume. So it is asking the question mark to be volume. What is the volume? I don't know, which means it's giving me the mass. Super, 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 super important step right there. Okay. Second step is, okay, well, I need to rearrange this so that I'm looking for volume. Right now, volume is at the denominator. I can't do anything with that, so I have to rearrange it. So I will, right? And I'll just use my rule of multiplication. I want volume to be by itself, which means I can swap the density with the volume, and then I would have volume is equal to mass over density. Notice again, the mass always just kind of stays right there. Okay? And now I'm ready to start the problem. Plug in stuff, right? Except, no, you're not ready. And I want you to look at this because we're going to do this on the test and we're going to do this throughout the year to you guys a few times. Make sure your units that are supposed to be the same are the same. What I mean by that is, look at this 7.9 grams and look at this 500 kilogram. These are not the same, right? It wouldn't make sense for me to start comparing these two things if they're not both in grams. So what you have to do is you have to first fix that. Now the question is, do I want to turn this 500 kilogram to gram, Or do I want to turn this 7.9 grams into kilogram? And the answer really comes from the SI, right? And what's the custom for density? Density, and I'll just write this here, density is always, always, always given to you in a number, and then the units are either grams, centimeter cubed, or you have grams, ml. So I will not turn this 7.9 gram to kilogram because it's not supposed to be in grams. Sorry, it's not supposed to be in kilograms. It's supposed to be in grams. So what I will do is, and I'll go ahead and erase this one because it's not right. I'm not doing this. I'm doing the opposite. I'm turning this 500 kg into grams first. Notice it's a lot of steps. It's a lot of thinking, okay? It takes practice, okay? Now, how I do it, I use it, dimension analysis. You can use the King Henry dance before the chocolate milk thing. I don't like to do that because I just like seeing it this way visually better. Okay, and how I'll do this is I'll say, okay, 500 kilogram, and again, I'll use dimensional analysis. Well, I know that I want to cancel out that kilogram and I want gram to be my end result. And I know that 1 kilogram is 1,000 grams. That means my kilograms cancel, and I have left with 500 times 1,000. I would just do it in a calculator to make sure you do it right, times 1,000, and you're going to get an answer of 500,000. Okay, so that's a lot of steps so far. So I'm going to erase this part. I'm going to say that we finally got to 500,000 grams. I'll scroll back up. I'll go back to the problem. Okay, so now I'll rewrite this 500 kilogram as 500,000 grams. 500,000 grams. Or I can use scientific notation and write it as 5 times 10 to the 6th gram, which looks a lot better. If I want to double check, is 500,000 to the 6th right? Let's double check it, and you'll find out that it's not right, and this is why I like to do all this stuff. 5 times 10 to the 6th. Notice I added an extra 0, so it's actually not to the 6, right? You want it to count 1, 2, 3, 4, 5 zeros, so that should have been a 6. So again, stuff to look at. If you make mistakes, there's nothing wrong with making a mistake. Just double check and correct it. That should have been 5 times 10 to the 5th because there's actually 5 zeros. And notice I double check. I'll double check here. 5 times 10 to the 5th. And I get exactly what I wanted to get. Now I can move on. Okay? All right. So let's move on from that. Stop. We'll go again with our formula. We said is volume is equal to mass divided by density, and everything else is just plug and chug plus sig figs. So volume is equal to mass. My mass we said was, I'll do the shorthand, which is scientific notation, 5, 0 times 10 to the 5th. I'm not done. I need my grams in there. Divided by my density, which was 7.9 grams over ml. And then I just plug that into my calculator. 5 times 10 to the 5th divided by 7. Oh, sorry. Let's backspace that. 5 times 10 to the 5th. You want to hit your arrow. Now you want to hit divide. Times 7.9. Execute. And that's going to bring your answer to equal to 6,000 63,291.14. Again, just because this is the answer you get does not mean that this is the correct answer. Check for sig figs, okay? Remember that the limiting factor with this is which one is the one with the shortest number of sig figs, okay? In this case, it's 2. If I would have written it like this, let's say I would have written it, which you guys would not have written it this way. I just like it because it's easier to look at. Let's say you would have written it exactly as what it is, which would have been 500,000 grams. That would have given you that the smallest sig fig is this bottom number with 2 sig figs versus this one that has 6 sig figs, and there's a little point there, sig figs. There's a little point there that I forgot, and if we look at the problem, you'll see that the little decimal was there, right? So really, if you want to rewrite that correctly, that's going to be 500,000 with a little decimal, which we just assume there's a 0 there, and grams. Okay? So there's a lot of things that could go wrong here in your calculation. Absolutely. All right? So we have established that our number is 2 sig figs if we're including that decimal. So we're just going to go ahead and say that our answer for this is 60. That's 1 sig fig. That means this has to be the last number included, which means this 2, if we round, doesn't really affect the 3, so we can just leave that 3 on there. 63,000. And that would be the end of the answer for volume, except it's not. Don't forget your units. That would be, notice we have grams ml. ml is the one that is given to us for volume, so we would write ml. Okay? I'm just going to make a quick list of things to check off here as a final check off list. Okay, so number 1, start with your formula. Number 2, you want to rearrange to whatever you need. Number 3, check your units are the same. Check units. 4, do your conversions if needed. Conversions. And number 5, always check sig figs. Okay? For this one, we needed the original formula, density equals mass over volume. We had to rearrange it to get volume is actually equal to mass over density. We had to check the units so that we saw that grams, and then we have to turn it to that kilogram in the problem, this kg, into those 500,000 grams. We had to do the conversion to finally turn it into 500,000 grams. And then we had to check for sig figs at the very end to make sure that we had the 2 sig figs necessary based off 7.9 to change this number and get the right answer. All right, that is it for this. If you need more questions, please stop for tutorials or message or email one of your teachers.